Good morning everyone. Today I would like to discuss a problem on inverse Laplace transforms. In this, how we are using the inverse Laplace transforms results properties. Okay. By using of those important results, we have to find out the suitable formula of the given function. It is in S variable. Okay. I am taking one problem and how I can find out the inverse Laplace transform of the given functions. Okay. One problem is find the inverse Laplace transform of inverse Laplace transforms of first one 1 by s cube, second one 2s minus 5 by 2s minus 5 by s square minus 4, third one 2s plus 1 by s into s plus 1, fourth one 3s minus 8 by 4s square plus 25. Okay. First, by observing the given functions, how we can find out the inverse Laplace transforms. We know that the Laplace transform of the function of t expressed in s variable, inverse transform of s variable can be expressed in t variable. Okay. I am taking first problem. Let f bar of s is equal to 1 by s cube. It can be written as 1 by s power 2 plus 1. We know that the Laplace transform of t power n is equal to 1 by n factorial by s power n plus 1, and from this L inverse of 1 by s power n plus 1 is equal to t power n by n factorial. Okay, this is the Laplace transform and inverse Laplace transform relation. If you remember Laplace transform, from that we can easy to find out the inverse Laplace transform. Whatever the constants are there, then those constants are taking to function of t side. Okay. Here s cube means this cube can be written as 2 plus 1. That is nothing but here L inverse of 1 by s cube, that is equal to, you subtract 1, that is nothing but t square by 2 factorial, that is equal to t square by 2. It is the first problem. Just in the place of n, taking 3 can be split into 2 plus 1, write t power n, that is t square by 2 factorial. 2 factorial equal to 1. It is the first solution. The second one is f bar of s is equal to 2s minus 5 by s square minus 4. Okay, just you think over. Here we write separately s by s square. Here 4 is a perfect square. It can be written as 2 square. Then 2 right outside, s by s square minus a square. That is the Laplace transform of cos h at. That is nothing but in the place of a, 2 is there. So we can write in the place of s by s square minus 4 is equal to cos h to t, and it is a constant, it is right outside. Then s square minus a square, 1 by s square minus a square means 1 by a sin h at. In the place of a, 2 is there, then you just write in the place of a 2. Okay, first it is in which relation? It is the suitable of Laplace transform of cos h at. Minus is in hyperbolic h function only. It is equal to s by s square minus a square. From this, L inverse of s by s square minus a square is equal to cos h at formula. By this relation, we can substitute in the place of a what is there, in the place of constant what is there. Okay, here one more thing, L of sin h at equal to a by s square minus a square. From this, L inverse of 1 by s square minus a square is equal to 1 by a sin h at. By using these two relations, we can solve the second one, simplify the second problem. That is L inverse of f bar of s equal to L inverse of 2s minus 5 by s square minus 4. By using linearity property, write separately. That is equal to 2 into L inverse of s by s square minus 2 square, constant right outside, minus 5 into L inverse of 1 by s square minus 2 square. In the place of L inverse of 1 by s square minus 2 square means just a is replaced by 2. This is equal to s by s square minus a square. It is equal to 2 cos h 2t minus 5 into 1 by 2 into sin h 2t. Then L inverse of f bar of s, that is equal to L inverse of 2s minus 5 by s square minus 4. It is equal to 2 cos h 2t minus 5 by 2 sin h 2t. It is the second problem. Simplification, that is the inverse Laplace transform of given function. Next, third one. Third one. Let f bar of s is equal to 2s plus 1 by s into s plus 1. Just you think it. Here 2s can be written as s plus 1. Then s plus s 2s. Why we can split into s plus s means just you write s plus 1 is a one term, s is one term, s cancel, here s plus 1 cancel. Then by using of partial fractions or directly by observing of the given function, you split into factors. Then it is s by s into s plus 1 plus s plus 1 by s into s plus 1. 1. Then here f bar of s equal to 1 by s plus 1 plus 1 by s. Then find out the inverse Laplace transform of f bar of s equal to L inverse of 2s plus 1 by s into s plus 1. It is equal to L inverse of 1 by s plus 1 plus 1 by s. By using linearity properties, write separately. L inverse of 1 by s plus 1 plus L inverse of 1 by s. Here we know that L of 1 is equal to constant, that is 1 by s. Then L inverse of 1 by s is equal to 1. Next, L of e power minus t is equal to 1 by s plus 1. Here in the place of a, minus 1 is there. Then if minus a means that is s plus a. From this Laplace transform inverse of s plus 1 is equal to e power minus t. Therefore, L inverse of f bar of s, that is equal to L inverse of 2s plus 1 by s into s plus 1 is equal to, in the place of L inverse of 1 by s plus 1 plus L inverse of 1 by s, it is equal to e power minus t plus 1. This is the third one. Next, fourth one. Fourth one is also, let f bar of s is equal to 3s minus 8 by 4s square plus 25. Here, in the denominator, taking common 4, it is s square plus 25 by 4. Here 25 is a perfect square, 4 is also a perfect square. It is equal to 3 by 4 into s by s square plus 5 by 4 whole square minus 8 by 4 into 1 by s square plus 5 by 2 whole square, or 25 by 4. Then L inverse of f bar of s is equal to L inverse of 3s minus 8 by 4s square plus 25, that is equal to L inverse of 3s by 4s square plus 25 minus 8 L inverse of 1 by 4s square plus 25. Here, write constants outside. In the denominator 4 is common. L inverse of s by s square plus 5 by 2 whole square minus 8 by 4 L inverse of 1 by s square plus 5 by 2 whole square. We know that L of s by s square plus a square is equal to cos 80, and L inverse of 1 by s square plus a square is equal to 1 by a sin 80. By using these inverse properties, inverse Laplace transforms, then L inverse of 3s by 4s square plus 25 is equal to 3 by 4 into cos 80. In the place of a, 5 by 2 is there. Cos 5 by 2 into t plus minus 4 1s are 4 2s are. It's 2 into 1 by a, that is 1 by 5 by 2. A is 5 by 2 sin a is 5 by 2 into t. This is equal to 3 by 4 cos 5 by 2 into t. 2 is numerator minus 4 by 5 sin 5 by 2 into t. These are the inverse Laplace transforms of given functions. Okay, thank you.